Hello, 8th graders. Lesson 3.5 is on similar figures, okay, and solving proportions. A similar figure is figures that have the same shape, but they're different sizes because the lengths of the sides are different. The angles are the same though, okay? That's also important with similar figures. These angles are the same, and they're the exact same shape. Now they might not be configured the exact same way. This triangle might be tilted down. And so then you have to figure out which sides are corresponding. Okay? But when you know that they're similar, then they are what's called proportional. Meaning that the sides correspond with each other. And then you can write a proportion. Okay? So, for example, big A, this side is similar to this side in the same way that C is to C. Okay? So if you put them on the same level, A is to A as B is to B. Okay? And as C is to C. Where would we write the big C? On the top line or the bottom line? On the top, to keep the pattern the same. Big C over little c. What else could we write as a proportion?
Numbers.
A is to B as what? A is to B in the same way as
lowercase a is to
correct.
Oh.
As lowercase a is to lowercase b. So they go together the same way. They're proportional.
So if you do that like that, what happens to C?
You don't need C.
Forever alone.
No, you could write C is to B as C is to B.
Okay.
Okay? But the point is, why you're doing this is so that you can substitute the numbers in and then solve it for a missing value. So we don't know what B is. We know what A and B are, but we don't know what B is over here. So then you can substitute the numbers in. So instead of writing, in this one, instead of writing A and B, let's put the numbers in and make a proportion. Aiden, do you know what?
So like, you could do 36 over 10.
36 over 10. Yep. So we're going to write 36 over 10 because those two are proportional. And then on the other side, you need to write
16 over B.
over B. Correct. 16 over B. Now, do you remember how to solve this?
Yep.
Cross multiply?
Yep.
Go ahead and do that. Go ahead.
Guys, you have to do it in a notebook.
Or multiply. What's 10 times 16?
1,600. Wait.
1. Yeah, we can just put 1 0 on the end. 160
160.
is equal to
36B.
good. And divide.
Oh wait, that's...
Yes.
B is 4. equals 4.4 feet.
4.4 repeating.
Yeah.
So round it to 4.4. Just round down to 4.4. What's the label?
Centimeters.
Centimeters, yep. Okay. Do you understand how to do these? And how they're proportional? Good. Go to page 149. On page, actually 151, we'll go over to 151. We just did the example, or one of the examples on page 150. The notes are on page 149. Let's do one from these two examples. Okay, first of all, you've got a person and a tree.
And a dog.
Where's the dog?
Oh, it's not this one.
Okay?
There.
And the sun is over here. Yep. So the angle that the sun is at is hitting both the person and the tree at the same angle, isn't it? And it's casting a shadow.
What?
And, wait, are we measuring
So here's
how-
the shadow of the tree.
It should be longer than the man.
That's unproportionate.
Well, that's because it's a scale, or it's a sketch. All right? So, they give us the length, that we can measure the length of the shadow along the ground, but you can't measure the height of the tree from the ground. But you can measure the height of the person from the ground, right?
I believe.
Yeah.
So,
Man.
let's put down some measurements. It says that the person casts a 3-foot shadow, and the tree casts a 7.5-foot shadow.
No way, Keyshawn, no way.
And the person is 5 feet tall. And what are we trying to find? What would it make sense?
The height of the tree.
The height of the tree, correct. The height of the tree. So we should assign a variable to that, right? Dylan?
12.
No, assign a variable to it. H for height.
Sure.
Okay. What is the height of the tree in feet, correct? So, we need to write a proportion that works. What proportion would work? Keyshawn?
5 feet over 7.5 feet.
Well, wait a second. We need to compare them in the same way. So we either need to compare these two in the same way, or these two in the same way.
5 over 3 feet.
Okay?
H over 7.
5 over 3 is equal to, no,
5.
5 feet over 3 feet
Equals
is proportional to
H over 6.
H over 7.5, right?
When,
That's not it.
when 3 over 7.5.
Okay, so this is the shadow, and this is the shadow. And the shadow goes with the height in the same way, correct? That's a true proportion. Okay? They're being compared in the same way. Alright? Is that the only proportion we can use?
No.
No, we can use 3 over 5 is equal to 7.5 over h.
Couldn't we put 3 over 7.5 and 5 over h?
Yes, we could. We could do that as well. Because these are, then we're comparing the proportion of the shadows to the height of the two objects. Okay? So there's many different proportions that we can use. Alright? You need to know how to do one more type of problem. If you want to look at the answer, that one's in your book, so you don't have to, but I'm not going to go through the answer on this. There's one other type of problem that you need to know. Oh, here's, the scale model, okay? No, let's go back. That'll be next. Okay. When you're given a map, the map uses a scale to help you figure out what the actual distance of something is compared to the distance on the map, right? And it'll give you a ratio, such as for map equaling actual distance. In your book, they give you a 1-inch map compared to a 10 miles of actual distance, right? 1 inch equals 10 miles of actual distance. Right? Why do they have to do that? You can't put a 10 miles on a map,
No, cause,
right? You can't
then
put.
it has to be as big as the world.
Correct.
Or you can use
So,
Google
it's
Maps.
like, okay, so we have to write 10 miles.
So we have to use a scale which tells us what the actual distance would be. Okay? It's really creating a miniature scale model of something. And then the scale will be a proportion. There'll be a ratio that tells you what is what. So if that's the case, then what is 1.75 inches of something? What in actual distance? Sorry, equals.
Oh, okay.
And so you can use a proportion to solve it.
Don't we just do the same thing as we did before?
Right.
Then
Look.
Then how is this like different?
Well, because it's a different situation. But the map, if you set it up this way, the map distance over the actual distance is equal to the map distance over the actual distance. Okay? So 1 inch to 10 miles equals, what's the third one?
175 inches
Yep,
to m miles.
to m miles, good. And then solve it.
Yeah.
Okay?
Wow, it's pretty much 10 times 1.75, and then you got the answer.
Yep. So you can set it up, and as long as you have the labels on the same level, you know you have a true proportion. Okay? All right, so I want you to practice these
No.
and do 3 through 6 and
Evens.
10 through 15. Okay?
Odds and odds.
3 through 6 and 10 through 15.
6 and 10.
Oh, 10 through, let's do 10 through 17. Okay?
8.